Now, in this video, we will going to take up one more problem on the projections of points. The problem reads as, a point is 20 mm below HP, is lying on VP, and 30 mm in front or behind or from LPP. Draw its projections and name the side view. We will try to analyze this problem. Here what he says that the point is 20 mm below HP and lying on VP. So since it is lying on VP, you have an ambiguity, whether it is in front of VP or behind VP. So that is the condition. And but below HP. So below HP can be seen. Where are the conditions you are going to get? To analyze this, below HP, it will be there in the third quadrant and as well as in the fourth quadrant. So this is how you can evaluate. If you have below HP, the condition is in third quadrant or it can be in the fourth quadrant. If it is behind VP, then it becomes third quadrant. If it is in front of VP, then it becomes the fourth quadrant. Now we will try to analyze this problem by considering the third quadrant. When you are considering this, when you are taking the below HP condition, when you are looking from the front view, you can see that below HP, the line which is the point is below HP by 20 mm is seen in the vertical plane. When you look from the front view, you can see that point directly on 20 mm below HP. Since it is lying on VP, obviously that point has to lie on HP. So when you look from the top view, the point is lying on HP. So that is the point which is P. And 30 mm in front or behind or from LPP. Since we are considering the third quadrant, so obviously the point should be behind VP, so behind LPP. So we have to consider the left side view. So when you are considering from the left side view, you can see below HP and also on VP. So obviously the point will be on HP now. So when you are looking from the distance 30 mm behind VP is seen in both, behind LPP can be seen in both VP and as well as in the HP. You can see that from this point to this point is 30 mm and also from this corner to this point it is 30 mm. So which can be seen when you look from the top view, you can see the distance, and when you look from the front view, you can see the distance. When you are cutting and opening that HP to the top and LPP to the left side, you can see that it has been rotated by 90 degrees. Correspondingly, the positions of the points is also being rotated. So here the point small p is on VP, so obviously that point will be on HP. And 20 mm below HP, so 20 mm below HP is seen in the vertical plane. You can see that 20 mm behind below HP, and 30 mm behind LPP. When you are projecting that, the top view, it will lie on the lying on VP, and obviously that point will be on x1y1 line. And when you are projecting that point P onto the origin and then it comes down, both front view and as well as the side view, both will going to lie on the same line. And since it is behind LPP, obviously you are looking from the left side view, so that is the reason why you have LSV here. Now we will try to analyze, once we analyze this problem, now we will try to solve this by using the sketchbook. When you first we are going to draw the XY line and the X1Y1 line and identify the quadrants. HP is above XY and VP is below XY. Since it is LPP, so adjacent to VP, you are going to write the LPP. Then as we see that the distance behind LPP is seen in both VP and HP. So from X1Y1 line, you measure the distance of 30 mm and you draw a vertical projector in the downward direction. And 20 mm below HP is seen in VP. So from XY line, you measure 20 mm and mark this point as small p dash. Then since it is lying on VP, obviously that distance has to be on HP. So that is the reason why you are getting on the XY line. So then we need to, when you are looking from the side view, obviously you can see both the top view and as well as the front view. So draw a horizontal projector from P dash to the x1y1 line, and through origin by using the protractor you measure an angle of 45 degrees and draw an inclined line. And draw draw a vertical projector from P to the origin, and then from here you project it down, and both these two lines will going to intersect at this point. You mark that point as P double dash. Then since it is behind LPP, obviously the view what you will going to get is the left side view. So the point P, capital P, lies in third quadrant. So that is how you are going to get this. Now we will going to try to analyze this problem by considering the fourth quadrant now. So when you are considering the fourth quadrant, the point is below HP and in front of VP. So obviously since it is below HP, so when you look from the front view, you can see the distance below HP or 20 mm. And similarly, since it is lying on VP, obviously that point should lie on HP. So you can see that point small p is lying on the horizontal plane. And since it is in the fourth quadrant, so obviously the point should be in front of VP. In front of VP means it should be in front of RPP. So that means I should look from the right side view, then the point will be in front. So when you are considering that, this will obviously it should be the right side view. So when you are projecting that, you draw a horizontal projector from P and also from P dash, and then through this origin you draw a vertical projector. Both these two lines will going to intersect at this point. You mark this as P double dash. And since it is the distance in front of LPP, obviously the distance is seen in the vertical plane, and as well as when you look from the top view, you can see the distance in the top plane also, that is HP. So now when you are cutting this here and rotate HP down and LPP towards the left side, then obviously you will going to get this as the second position. The distance B in front of LPP is seen in both VP and HP. Since both VP and HP is on the below the XY line, so from here you measure 30 mm and you will going to get this line. And then below HP is seen in VP. Since it is in VP, obviously that point is the front view. So you mark that as P dash. So then you measure the distance, that in this is going to be 20 mm. When you are looking for the profile view, it can see both the top view and as well as the front view. So from P dash you are getting that point here. Then from P you draw a horizontal projector, and where you have the origin, from there it will comes down. Both these two lines will going to intersect at this point, which will going to become P double dash. Since it is in front of LPP, obviously the view what you will going to get is the right side view. So this is how you will be able to analyze both in 2D and in the orthographic view. Now we will try to solve the problem by using the sketchbook. So first, initially what we are going to do is we are going to draw an XY line and the XY line with a little bit thicker than the projector line. Then identify the planes. What are the planes? Since it is LPP, you write below XY line and to the left of X1, Y1, and VP and HP is the one which is being rotated. So as we see that the in front of LPP is seen in both VP and HP, so obviously from X1, Y1 line you measure the distance of 30 and you draw a vertical projector which should be a very thin line. Then since it is 20 mm below HP, so from this point you measure 20 mm and you mark that point as P dash and then give the dimension as 20. Since it is lying on VP, obviously the point should lie on HP, so you mark that point as small p now. So as we know that in the side view you can see both the front view and the top view. So from the front view you draw a horizontal projector to the X1, Y1 line. Similarly from P, that is the top view, we draw a horizontal projector and it will meet at the origin, then it project down, both will going to intersect at this point. You mark this point as P double dash, then this is going to be the right side view. So this is how, and show the dimensions. So this is how you will be able to analyze and draw the solution in the sketchbook. So obviously since it is the fourth quadrant, the point P lies in the fourth quadrant, and this is going to be the final solution. But suppose if you get this type of problems in the examination, give only the one solution. Either the point lies in the third quadrant or it can be in the fourth quadrant. But however, you need to write the point P lies in third as well as in the fourth. But in the third quadrant, the side view will going to be the left side view. But in the fourth quadrant, the side view will going to be the right side view. So this is how you will be able to analyze this particular problem wherein the point is lying on VP. So thank you.